Okay, let's try naming some bicyclic compounds. If you look at the first two compounds that I have here, they're obviously both bicyclic compounds. They both contain 7 carbons, so they would be some kind of bicycloheptane. But if I were to call both of them bicycloheptane, that's not enough information to differentiate between the two of them. So I first start by identifying the bridgehead carbons. Those are the 2 carbons where the rings are fused together. So I've identified the 2 bridgehead carbons in red on the compound on the left, and if I look at the compound on the right, I can see I have 1 bridgehead carbon here, and I have another bridgehead carbon here. So when I'm counting the carbons in the bridges, I'm going to not include the 2 bridgehead carbons. So if I look at the compound on the left, you can see, I'm just going to get a different color pen here, you can see I have 1 bridge here that contains 1, 2, 3 carbon atoms. I have another bridge here that contains only 1, and I have another bridge here that contains only 1. So what I'm going to do with those numbers is I'm going to order those numbers. So first I'm going to call this compound bicyclo. Bicyclo. And then I'm going to open a square bracket like this, and then I'm going to put in brackets, I'm going to put the numbers of each one of those bridges going from largest to smallest. So I have 1 bridge that has 3 carbons, I put a period. I have another bridge with 1 carbon, and I also have another bridge with 1 carbon. So I close the bracket. So that's going to be bicyclo 3,1,1 heptane. And this one here on the right, you can see that the bridges, hopefully, you can see I have 1 bridge that has 2 carbons in it. I have another bridge with 1 carbon, and I have another bridge here with 2 carbons. So this one is going to be bicyclo 2,2,1 heptane. And that way we differentiate between those 2 bicycloheptanes. So if we go down here to the next example that I have, again, you can see I have 2 bridgehead carbons here. If you count the number of carbons overall, I have 1, 2, 3, 4, 5, 6, 7, 8. So that would be an octane, but it's a bicyclooctane. So I'm going to start by writing bicyclo. I'm going to open my square bracket. If you look at the bridges in this compound, you can see I have 1 bridge here with 2 carbons. I have another bridge here with 2 carbons. I have another bridge here with 2 carbons. So they all have 2 carbons. So I don't have to worry too much about the order in this case. So bicyclo 2,2,2 octane, like that. Okay, so let's move on to something with some substituents on it. So if I look at this bicyclic compound here, again, I'm going to start by identifying the bridgehead carbon. So I have a bridgehead carbon here, I have a bridgehead carbon here. Those are the carbons where the rings are fused together, or stuck together, if you will. Now I'm going to look for the bridges. So I can see in this case, I only have 2 bridges that contain carbon, so I have one here. This bridge has 4 carbons in it, so 4 carbons here. This one has 3 carbons in it. And then there's no other bridge, so the last bridge is going to be 0 carbon. So if you look in between these 2 carbons, the 2 bridgeheads here, there are no other carbons, so my last bridge would be a 0. So I'm trying to erase that. There we go. So let's put 3 carbons here, 4 carbons. So if I count up the total number of carbons in the ring system, it's a nonane, which means it has 9 carbons, because I have 6 carbons total in this ring here. If I number them, I say 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is some kind of bicyclo-nonane. So I could write that down and say I have a bicyclo-nonane. But then what I would want to do is make sure that I include the bridges. So I'm going to put bicyclo, start with what we know. And if we look at our bridges, we have 1 bridge with 4 carbons. We have another bridge with 3 carbons, another one with 0. And then I'm going to put nonane at the end. Then all we need to do is name our substituent. So I have an ethyl group here. I have an ethyl group here. And down here I have a methyl group. So ethyl is going to come before methyl because E comes before M in the alphabet. So this is going to be a 7 ethyl, 2 methyl. And I don't have to have that B capitalized, so I'll just fix that up. 7. So 7 ethyl, 2 methyl bicyclo, 4,3,0 nonane. And I want to point out the numbering. Why did I count those rings in the way that I did? Because you have to start at a bridgehead carbon. You always start, number 1 has to be at a bridgehead carbon. So it'd have to be at one of these 2 carbons. But I'm going to number it in such a way that, again, same as always, I want to give the substituents the lowest number possible, and I always start with the largest bridge, of carbons. So if I had decided to go this way, I would be going on a smaller bridge, a bridge of only 3 carbons, as opposed to going this way on a bridge of 4 carbons. So clearly you can see I'm going to start on the bigger ring, the one on the left. Now if I'd started at the top here, if I'd started on this carbon and I had gone sort of counterclockwise, if you will, if I had said 1, 2, 3, so on and so forth like that, then I would have given this methyl group the number 1, 2, 3, 4, 5. It would be 5-methyl, so this will give you a higher number. So you always want to give your alkyl substituents the lowest possible number. If I look at this last example here, so this is very closely related to the bicyclo 222 octane that we looked at before. So again, if I just start by identifying my bridgehead carbons, you can see that all the bridges are the same in the length of carbon atoms, but obviously I want to give these 2 methyls, I want to give this dimethyl the lowest possible number. So I'm going to start here, I'm going to say 1, 2, 3, 4. And then for the other 2 rings, it doesn't really matter which way I go. I mean, I could go 5, 6, 7, 8, or I could have gone the other way because there's no discernment between those 2 bridges. They're identical. So how would I name this compound? Well, I have a 2,2-dimethyl, so I'm going to put 2,2-dimethyl. 2, 2, 2, oops. Did I forget bicyclo? I think I did. There we go. Bicyclo 2, 2, 2 octane. So, to summarize, you're going to count the total number of carbons in the bicyclic system. So that's going to define whether it's a bicyclo, hexane, heptane, octane, nonane, etc. Then, once you start looking at the bridges, you identify the largest bridge and the second largest bridge and the smallest bridge, so on and so forth, and you're going to number those inside the square bracket, starting with the largest number, going to the smallest number, and then you want to number it or go through those bridges or number those bridges in such a way that you give the substituents the lowest possible number. And I hope that gives you a little help in naming bicyclic compounds.